Welcome to qnawire.
Okay, we have the following transformation. A substrate with bromine on a primary carbon after some number of reagents will give us a same carbon skeleton, but the bromine has migrated to a secondary carbon neighboring the carbon which initially paired the bromine. And the question is, what sequence of reagents will best accomplish this transformation? And so what we are looking at here very likely is that we will do something which generates an alkene and then installs bromine via Markovnikov addition of bromine. So that's elimination, followed by addition of bromine in a Markovnikov fashion. So the question then becomes, what reagents can accomplish elimination, followed by, in the second case, addition of bromine in a Markovnikov fashion? Well, elimination, we're going to want a base, right? But in particular, we're going to want a bulky base so that we don't have a competing substitution reaction. Bulky base, i.e. non-nucleophilic base. Okay, and so if we look at our options, we have potassium T-butoxide. That's our first option, and right away, this is exactly what we're looking for. Potassium T-butoxide is a non-nucleophilic base, right? Our other options would be B, which is sodium ethoxide, right? But ethoxide ion is nucleophilic, and therefore we would have a competing SN2 reaction. C is beginning with H2SO4 and heat, which will not cause an elimination reaction for a hydrogen halide, so that's out. Likewise, B is out here for the reasons we discussed previously. We can look at D. We have H2O, right, is our initial reagent. This is a weak base, weak nucleophile. We'd much rather have a strong base to affect an elimination reaction. And when we have a weak base, weak nucleophile, again, we have competing substitution and elimination products, so that's no good. Okay, now we say option E is A or D work equally well. We know that not to be true because D is a weak base, weak nucleophile. So right away, just based on the first reaction, elimination, we've been able to rule out B, C, D, and E, but let's confirm that the second step of A will work. So recall the first step here was our potassium T-butoxide. The second step is HBr, which is perfect because that will install bromine across the double bond in a Markovnikov fashion. So A is definitely the correct answer.